This is Non-AP Calculus Spring Review Worksheet 2. We're just going to go through each of these problems one by one. For number 1, use right-handed rectangles to approximate the area using 4 subintervals. So rectangles takes on area formula of width times height. So the width, first off, the width is going to be each subinterval. Make sure that we see the same number of order pairs. So because we're spanning all the way from 2 to 27, we're going to make each subinterval cover or span across 3 different order pairs. And each subinterval is going to share the same order pair from the previous subinterval. Okay. And now, if we just subtract the 2 x values, we're going to get the width. So 7 minus 2 is 5. That's our first rectangle has a width of 5. And it says right-handed rectangle, which means that we want to choose the height of that's connected to the right endpoint. So the f of x is going to give us information about the height. The x is going to give us information about the width. So 7 minus 2 is 5. That's a width of 5. Height is going to be 2. So 5 times 2 is the area of the first rectangle. Second rectangle, 16 minus 7, it's 9. That's a width of 9 and a height of 6. 9 times 6, 5 times 12, and then 6 times 10. We add the areas of those rectangles, and this is an approximation of the actual area under the curve between 2 and 27. Okay, for number 2, use trapezoidal sum to approximate the definite integral from 2 to 30. And the area formula for trapezoid is width over 2 times height 1 plus height 2. So our width is going to be, we're still going to make sure that every subinterval sees the same number of order pairs. And we're still going to subtract to find the width. But now we have a different formula because we have a different shape, geometric shape that we're using to approximate the area. So width over 2, that's going to be the width is 6. 6 divided by 2 is part of the formula. And then height 1 plus height 2. So height 1 plus height 2 will always be the 2 endpoints of our subinterval. So 0 plus 6, that's going to be representing the height of my first trapezoid. Second trapezoid is 7 over 2, and then 6 plus 3. Third trapezoid, 7 over 2, and then 3 plus 12. And then last trapezoid, 8 over 2, and then 12 plus 12. Total them up, we have 4 areas of trapezoids. We get an approximation of 198. Okay, number 3, find the derivative. So before we can find the derivative, let's set this up so that we can apply chain rule, because this is not something that we can just expand all the way out because of the parentheses and the negative exponent. So we're going to bring this radical up to the top, make it 5/4, but then we're also going to make it negative 5/4 because we want this denominator to be up in the numerator. Okay, so hopefully we can see the need for chain rule. There's an outside portion and there's an inside portion. The outside portion is the 2 parentheses to negative 5/4, and the inside portion is the these terms between the parentheses. Okay, so we take turns with each of their derivatives. With the outside derivative, we keep the 2, we multiply by the negative 5/4, so 2 times negative 5/4 is negative 10/4. We keep the parentheses intact, and then we subtract 1 from the exponent. Okay, so minus 4 over 4, which gives us negative 9/4, and then what fills in here is going to be the original inside function. So it's going to be the e to the 2x minus natural log of 6x. Okay, and then we multiply by the inside function's derivative. So inside function, we have 2 rules here. The rule for e to the u is e to the u times u prime, so e to the 7x times 7, that's here. And the natural log of 6x, that's the u value here, so u prime over u is 6 over 6x. So now we should have to clean up. We're going to push this down to the denominator because of the negative exponent. That's going to share the same space as the 4, and what's up top is the negative 10 and the parentheses. And I can clean this up a little bit more. 10 over 4 reduces to be negative 5 over 2. All right, number 4, we have an extended natural log expression. So the first thing we should do is try to expand first before we jump into our derivative rule. So our rule for this falls under the pattern of natural log of a times b. The a value is the 5x, and then the second set of radical is our b value. So I'm going to rewrite this, expand it out, because if we can expand first, then our u prime over u derivatives will be a lot easier to manage. Right? So our a value is 5x, our b value is the 3 minus 6x squared raised to the 7/2. So that's my natural log of a plus natural log of b. We're going to push this exponent down in front, the 7/2. So this is now fully expanded. We have two separate natural log terms. We can do u prime over u for each of them separately. So 5x becomes u prime over u, 5 over 5x. For the second expression, 7/2 stays, and then we do u prime over u for our parentheses. So the derivative for 3 is 0, the derivative for negative 6x squared is negative 12x, divided by 3 minus 6x squared. Clean this up a little bit more. The 5 over 5x becomes 1 over x, and then we can cancel out the 12 and the 2 and push these to be the same under the same fraction, but we can leave these two ultimately in two separate fractions. Okay, so number 5, use implicit differentiation to find dy dx. We have a lot of expansion. Well, we have an expansion opportunity here with the first set of expression, with the first term. So I can go through quotient property. Natural log of numerator over denominator is the same thing as natural log of numerator minus the natural log of the denominator. So I'm going to use quotient property, natural log of 3x minus natural log of 5y raised to the 1/2. I can further expand this by pushing that 1/2 down in front. Now I have all my terms expanded. I'm going to now move to my derivative rule for each term. So natural log of 3x becomes 3 over 3x, u prime over u. Natural log of 5y becomes 5 over 5y. Now notice that this requires implicit because we have y's all over the place, unlike previous terms, unlike previous problems. So every time we come across y and we're asked to find the derivative, we have to make sure we multiply by dy dx. So 5y becomes 5 over 5y times dy dx. E to the 6y, remember the rule for e to the u is e to the u times u prime. So the rule for e to the 6y is e to the 6y times 6, but we have that y involved, so times dy dx. 5 pi is just a number, so that's going to go away to 0. 5x cubed becomes 15x squared, or negative 15x squared. And negative 4y squared becomes negative 8y times dy dx. We have our derivative in front of us. We just have to kind of rearrange it to solve for dy dx. So I'm going to group my dy dx terms together. These are my 3 dy dx terms. I'm going to make them all, move them, add and subtract in a way so that these 3 terms are sitting on the same side of the equation. Okay, so move the 8y over. I'll keep these 2 dy dx terms together on the left side. On the other side, I'm going to move the non-dy dx terms. So negative 15x squared is already on the right side. We can leave that there. I'm going to subtract the 3 over 3x, which reduces to be 1 over x over. I can then factor the dy dx term out, divide the parentheses over, and there's my slope formula for whatever this graph looks like.